So now we can go for the placement of bigger component as we have planned. So let's open the image, that image as well. It will be easy to prefer those. Okay, perfect. So firstly, I'm just going to remove these designators. So for that, what you have to do, you have to just select one, press Shift F, select it again, and then this find similar object window will open. From here you have to select the same, and then all the that means all the designator will be selected, right? And when you press OK, all the designators are selected now. Now using this I button, you can able to hide all the designators. It is simple, right? I've already told you on some of my videos and all the stuff. Anyways, so let's place the blocks. I'm going to split the screen. Okay, so from previous few placement, I just want to verify one more time how I place those. So I just don't want to guide you in the wrong direction. So firstly, open those PCB file one more time that I've shown you, and those was okay on this folder again, and project file. I'm going to share those after the placement for the reference. If you want, go to the option 1, open this PCB file, and we will check with respect to this marker, okay, where that marker is exactly on this one. Okay, we have the right placement here for the SOC. So I'm just going to close it again. Okay, so we have placed those. Let's place all the big components first. So what is the next? Let's go for the LPDDR4, and we have those on this line. So this is the first LPDDR. Let's select that section. Okay, and we're going to place that on the bottom layer, and let's place it somewhere here, and let's verify the connections. So see, we are using 2 DDRs, right? So one DDR connections will be at this side, and another DDR connections will be at this side, right? So if we'll place this DDR at this position and this DDR at this position, then we have to just change all the placement again. So I'm just going to verify with how you can verify. Just go to the view, connections, and show all. Okay, so as you can see, all these DDR connections are like that. Okay, so how it will be routed? This byte group will be routed like this. This byte group will be routed like this. This byte group will be routed here in this section, and another next to this section, the another byte group, which we can route on the another layer. So it will be like pretty forward connection when we're going to use 2 signal layers. Let's place another one, and we can able to change the orientation whenever we want. So just select another one and just change the layer and place it like that. Okay, so here I'm just going to place all the big components first. Let's remove. Okay, so here we have placed our DDR4s, and this area we needed to if you want, you can just shift it a little bit on this direction. Later we can adjust, obviously. So this area we're going to use especially for the length matching, right? Because for length matching we have to split the split the connections, right? And yeah, so that's why and we have few connections which will be like common between the banks of RAM, right? So for that also we needed space. Anyways, we'll see that during the routing. Now we'll go for another section that we can place. Let's go for eMMC. Select that. And just drag it. So as you can see, it is pretty direct connection, right? And you can place this here. Okay. So here you can see few clearance problem. That is because of pad-to-pad clearance. So that you can easily go to the design rules, go to the clearance, and from here click over the ignore pad-to-pad clearance, apply OK, and this will be removed, right? Okay, let's move to another block. So apart from that, okay, another blocks are Type-C connectors. So let's place those as well. So where we have Type-C, so here we have one Type-C connector, and that is the power one. So we're going to place it somewhere here. just remember we have copper on this section, so just make sure these things are not touching each other, or we have enough clearance. That we can verify from the design rules as well, but the symbol is properly designed, so you can just place it on the edge. And this is the connector or USB that we have to insert, so it should have like nearly touching to the edge, right? Apart from that, we have another type C that we are using for programming and debugging purpose. So let's select that as well, and this will be connected somewhere else here. Okay, so here you can see we have this 3D body is coming out of this the footprint that we have designed. So the reason behind it is I can't able to find the 3D model of this type C, which has these number of pins. So what I did, I basically whatever I found, I just placed it, so we can we can kind of we have some you can say some 3D model, so by that we can able to just guess, okay, we needed this much clearance or not, right? So that's why we add 3D models, so we can able to guess the height of the chip, and the board that we are designing, we can kind of guess the clearance between the connector or the component to component, like that, right? Using 3D body, it's kind of helpful. Okay, anyways, we have placed these block as well. Apart from that, let's place Wi-Fi module and their connectors as well. So let's go to the Wi-Fi module, and so this is our module, and rest of the component we're going to place later. Okay, so how it will be connected? It will be connected, okay, that we have to see with respect to connector. Here we have to adjust this one. Okay, so this is the boundary, right? This is not the component part. Okay, I place that external part which will be like similarly for the Wi-Fi module. So Wi-Fi module is in this section, right? And you can see here the enough clearance. If I'm going to measure that, Control M, it has like 2 mm of clearance between those, right? Let's remove that measurement. Okay, let's place the connector first. So by that we can guess the side, which side we have to place at which direction. So this is one connector, which we're going to place here. This is another connector. So again, the Wi-Fi that we are using is dual band, right? And which is here. Okay, so the side of the size that we have to, where we have to the orientation of the Wi-Fi module is correct, because see, this is connected to this line and this is connected to this line, so it will be like pretty direct connection of the RF signals, right? Okay, and we have markers here as well, provided by the DXF provided by the manufacturer. So here they are recommending we have to just remove the copper or the ground copper under those RF tracks. And yeah, apart from that, it will be on the same layer, it will be properly isolated with the ground. Anyways, so this is our Wi-Fi section, the major component. Apart from that, we can place the PMIC as well. So open the PMIC, where it is. Okay, it's here. Just select the chip and just place it in this direction. So we're going to place PMIC here. Apart from that, we have few more switches that we are using. So those are again some bigger component, and we can place those in this section. Okay, so like that. And later we will see which switch is going where, and according to that we'll adjust the order of those. Okay. Apart from that, what else we have to place? We have placed type C connector, this here. And yeah, apart from that, we have all the buck converters, and just go through with these one. Okay, we have Ethernet PHY as well. So for that, we'll just select those. And again, you can see it is at the same corner as I already told you. So just change the layer and we'll place it somewhere. So we can't place the Ethernet PHY on this section, like exactly on that. Yeah, we can place, because we're going to route all the high-speed tracks on the internal layers. So there will be vias which will be blind vias. So that means those vias will be exposed on the top layer, but on the bottom layer we can place the component. Okay, so you can just place it somewhere else, or we'll just adjust that later. Okay, so till now I guess I placed all the major components. Let's check one more time. Okay, the biggest component that we forgot, that is our DDR4 connector. Okay, so these DDR4 connector will be aligned on these lines. Okay, these pads are given, as well as you can, here we have this notch also, right? So you can align this on this notch. So how to do that? Firstly, select that component, go to the reposition selected, and here we have this. Just rotate it. Okay. So with bigger component, you'll kind of see few, some lag. Yeah, that's it. And just place it as close as possible to notch. Now we're going to change the grid, and we can just change it to very fine grid. Okay, so before aligning that with the notch, I'm just going to, so as you can see, all the colors are very solid here, and I always kind of prefer some 30 to 40% transparency, so everything will be clearly visible. Whatever, how we have routed the signals, or it is properly connected to the pad center, or we just connected at the corner of the pad. So that thing is clearly visible when you go for this much transparency, right? So let's close that. I'm just going to merge it again, and let's align this. So as you can see on this section, you can see these fine dots, right? So on this section, it is aligned. Okay, hold on. Yeah, but we have to align on the, it should be at the middle of the thing, right? So now it is proper, right? Similarly, we'll verify with the pads that we have assigned. So okay, if we'll press the top layer and hold on. Okay, so this is the pad, right? And you can see it is properly on the pad, right? How you can do that? Okay, hold on. Let's check which layer that they are using for this representation, and then we're going to enable that layer only, and we're going to hide all the other layers. So just go to all the mechanical layers and see which one is representing the top layer only. Okay, so this is the bottom one, and this is the top layer, which is mechanical 5. Now what I'll do, I'll just click over this one, go to the layer color, scroll down, click over this, and this will be top plus mech 5. And what I'm going to do, I'm just going to hide all the other layers except top and mech 5. Okay, and just save this, close. Here you'll find that top and mech 5, and just press Shift S, and here you can see, right? So now we have another thing that from that we can align that properly. So you can see there's a very fine gap between those, and let's see if we can align those. Okay, so this is the perfect position for this line. Now we'll go back to all the layers and Shift S, sorry, Control S, so save the project. Now select this and lock. Okay, so we have locked this position. Now The next step is we have to place the mounting holes, fiducials, and whatever the other holes required. So for that, I'm just going to split the screen one more time. Just select all the mounting holes together. And these mounting holes can be, depends on your carrier board where we're going to place the SOM. So let's select the reposition those and properly align it. Okay, this is one is here. Okay, so I would recommend just enable the snap, so it will be automatically snap the component under the hole, right? So here you will see few clearance issue. Okay, it's not because of clearance, it's because of we were hovering the component, and this will be assigned on this one. Okay, one more left. Okay, so it's already snapped that on the location, right? Okay, so here we have few clearance issue. For now we can ignore that. Okay, so it is, there we go. For that we have to just shift it here. And yeah, this one we can ignore, and here these are okay. So for that one solution is just go to the footprint of this particular hole, and whatever the pad size apart from hole size, you can just decrease that. So let's go to the footprint and let's see what is it is by default, and we'll just decrease that to maintain the clearance, because we are using this for mounting holes, right? So merge all, go to this one, search for SOM mounting hole, select that, double click on this one. Okay, so it has hole size 2.2 mm and the pad is 4 mm, right? So let's go for 3.1, and I guess this would be helpful. And for replacing those, just right click on this and update with SOM mounting, and it is select all the layers, so all the layers will be also updated. Just go back to the project, see, okay, so now we have like more area to adjust those. Similarly here, okay, same thing you can do in this section. Okay, so again, we're not going to use these two mounting holes. These are just few extra mounting holes for, okay, we will going to use those. So yeah, because we're going to place a heatsink on this one, heatsink and fan, and that will be placed on this one. Okay, so here okay, what is the clearance constraint? If you'll check on the violation, so it is defined at 10 mil, right? And if I'll place at the center of this thing, what is the clearance issue? Okay, so it is saying it is collision. Okay, so that collision is happening because of this marker, and obviously this part is going inside this thing, DDR4 connector. Okay, so we don't have any option, we have to just adjust this mounting hole, and yeah, that's it. So when like whatever the heatsink position on this one, it will be on these 4 holes, 1 2 3 4. Okay, and these 2 will be used as a mounting hole, and yeah, on this side we don't need a mounting hole because it will be, the card will be inserted on the DDR4 using these 2 locks. Okay, apart from that, yeah, so now let's see what is the next step, and we're going to just select all these mounting hole and log those as well. So in future, because of routing, we can't, we can able to change the position of those, so it will be locked. Okay, this is one thing. Let's open this one again. So start the component placement block wise with the schematic. Okay, before that, okay, we did the planning. Firstly, we'll do the place the big component as per the planning. And okay, now the next step is we're going to assign few colors on the power nets. Okay, and the reason for those is, so right now see everything is red here, right? And the component is so big, so until you zoom so much you can't able to see the net name, right? Because these are just very small pads, and if you see the dimension, it's like 12 mil cross 12 mil, right? It's very small. So for that, what you have to do, you have to just open the, so we'll start from the power pins, and that's why I placed that on a single block. So let's assign the net color on these. So for that, go to the view, set net color, and just start from, so see, we can't assign blue color because okay, we can, because our component at the top layer, we can't assign red. Okay, so let's say this is one blue color, which is CPU_L for the little architecture. Apart from that, we're going to set another color, which is, let's suppose, green color on the logic. And similarly, we'll go to assign another color, let's suppose yellow on the center logic. There's no point to assign the same color, right? Because then we'll confuse between the net labels. Again, go to the view, set net color, and let's select dark green for GPU, and again go to the view, set net color, and let's select this one for, okay. Now we have to save that and import on the PCB file, design, import changes. So it will import all these RGB configuration, and here we go. Okay, so now we know where we have to place the component. So here we will start. Okay, before that I wanted to show you how I did that 45-degree configuration. I hope you people know that. So for that you have to go to the setting, and from there open the schematic, go to the general, PCB, go to the general, and here you'll see the rotation step, and you can just change it to 45-degree, right? Because our component placement required that. Yeah, and if you'll go for you can analyze by yourself. If you'll go for if you wanna place this at 0 degree, then you will see the placing all the other components will be so much difficult, right? So you can analyze that by do that placement as well. And everything will be placed inside these shielding markers, right? Apart from these antennas and few switches, because those are just normal connections, right? We have to just pack everything inside every high-speed signal inside their shielding. That is one thing. Let's start with the component placement. So how to do that? It is simple, right? So just target one block. Let's start with CPU_L, and where is that? We have these capacitors here. Just select those. Okay, so what should be the thought process for component placement? So we do component placement several times whenever we're designing complex board like that. Okay, so the first component placement will be for to just make sure our area of the board is enough for all the components. So this is the, okay, we have placed these as well. Let's highlight those. Okay, so you can say iterations of component placement, and hold on. Okay, so the first iteration will be for just make sure the board area is enough for all the components. Okay, then we do another iteration and that iteration is when we do the layout. Okay, so we kind of rearrange everything as per the to avoid all the cross connections, to follow all the design guidelines, right? So another is the placement which supports the layout. Okay, this is another iteration. So I just mentioned that iteration 2. Okay, now when we do the layout, after that there are several iterations of layout optimization. Okay, so then at that time also we change the component placement. So you can say this, just play with the almost final position of component during the layout optimization. Okay, so these are the three placement iterations that we have to follow during the design. And again, these are in loops, right? So like so many times you have to just review the layout and review the schematic. Sometimes you found something, after the layout you found something missing on the schematic, and when you add that component you have to adjust the position again, and you have to delete a lot of tracks as well, right? So this is a kind of closed loop, and so many times whenever you try to optimize something, you have to just change the location or the position of component.